Hello, everyone. Now, last time we talked about quadratic equations and their formulas, the quadratic formula, which is shown up here on the screen. Now, if you didn't watch that video, please do go watch it. It's very important content for this video. Now, if you tried using them a few times, you soon realize that the number under the square root b squared minus 4ac is pretty important, since it determines what type of roots you're going to get. For example, if it's negative, if this b squared minus 4ac is negative, then there are going to be no real solutions, since you can't take the square root of a negative number and still get a real number. And it works the other way as well. If you have no real solutions for a quadratic equation, then this expression b squared minus 4ac will be negative. And if this b squared minus 4ac is equal to 0, you will see that the two roots are equivalent, since the plus minus is 0 after all. So you can get that, and you get that the value of these two are negative b over 2a, since the entire part about b squared minus 4ac square root can be omitted since it's 0. And finally, if it's positive, then you get that the two roots are not the same, are distinct, and yeah, they're just the value of the quadratic equation. So since this value is so important, we gave it a name. It's called the discriminant, sometimes also called the discriminant. Yeah, basically. And to have rational roots, to get rational roots for a quadratic equation, you must have a discriminant that's a square number. It has to be a square number, and to have integer roots, pretty much first it has to be a square number, since it has to be rational, and then the entire top part, the entire numerator portion of the quadratic formula, negative b plus minus the square root of the discriminant, must be divisible by the denominator two-way. Now here's an example using it. The question reads, find the value range of k, such as the equation k minus 1 times x squared plus 2 times k minus 7 times x plus k plus 2 equals 0 has two real roots. Now, since we know that the equation has two real roots, we can get that the discriminant must be larger than or equal to 0, or just positive, or equal to 0. Then that means, and since the discriminant is b squared minus 2ac, b squared minus 2ac, you can just substitute b equals 2 times k minus 7 and a equals k minus 1 and c equals k plus 2 into these to get 2 times k minus 7 squared minus 4 times k minus 1 times k plus 2 to get that the discriminant is equal to negative 60k plus 204. Then you can just substitute the value of the discriminant into the fact that the discriminant is non-negative to get that negative 60k plus 204 is larger than or equal to 0. But then there's a very important part that many people miss when you're doing questions in competitions or tests, and that's that for this to be valid, for the equation to even have two real roots, it has to remain a quadratic. So if k minus 1 is 0, in which case after simplification there is no x squared term per se, it's no longer a quadratic and therefore does not have two real roots. It doesn't have two roots at all, right? In fact, so k minus 1 must not equal 0. From that, you can get that k is less than or equal to 17 over 5, and k does not equal 1. And here's two questions for you guys to try on your own. Pause the video now if you want to try them. I'll show the answers very soon, basically. So here are the solutions to these two questions. Thank you for listening. Bye.